Welcome to Cpp.chat, a sometimes weekly look at what's going on in the world of C++, chatting with guests from the community. I will introduce this week's special guest in just a moment. But first, I'll hand over to John, who really needs to read a disclaimer.
Thank you very much, Phil. Reproduction is authorized, provided the source is acknowledged, except where otherwise stated. Where prior permission must be obtained for the reproduction of information, such permission shall cancel the aforementioned general permission and shall clearly indicate any restrictions on use. Thank you very much. It's important for us to read the disclaimer every episode. I do want to apologize for Jordy Mon, who Jordy sent us a message saying he thought the disclaimers were all real. The truth behind the disclaimers is that these are all real disclaimers. I find them somewhere on the internet, and like the one I just read, they strike me as preposterous, and so I have to share them. And so that is the purpose of the disclaimers. Anyone who actually wants to share information in this episode, we appreciate that.
Share and share alike.
Share and share alike. That's right. We have an interesting story with this episode. We have Nico Josuttis. Did I say it right? Josuttis? No, not right. Nico is back. We interviewed him just recently because we interviewed him live at CppCon with a live audience at CppCon, but we had some audio difficulty on that, and so it looked like that wasn't going to be an episode. But we're looking at that now and thinking maybe there's enough to salvage that could be an episode. So we're in an iffy situation there. We now have a situation where we are going to have this episode, and we may in fact have downstream from here, we may have another episode that actually was recorded before this episode, and we can't even tell you for sure if that's going to happen. So did I get that right? Did I explain that correctly?
I think so, but I think I need a time machine really to tell.
Anyway, welcome, Nico, or welcome back.
Hi there.
In the previous episode, I don't recall what all we talked about, which is kind of a problem because we may be somewhat repetitive, or we may the two may not fit together. But I do know one of the things that we talked about was the class that you had just given, and it's time now for people to submit classes for CppCon. Technically, the deadline is passed, but if someone has a class that they want to make a submission for CppCon 2019, it is still possible to get that in. Just ignore what the deadline says and go to cppcon.org, read about how to make a submission for a class, and go ahead and submit. If you do that in the next couple of days, it's probably going to be fine, even though technically it's past the submission.
I did a class at CppCon last year, and my review is AAA+++ would do again.
AAA+++. You're crazy guys.
Will do again. How about you, Nico? Have you submitted again? I think you said you had.
I had. I was interested. I talked to you because last year I gave this advanced C++ training. So for all the people who learn C++ and then forget about the details, and new details are coming, and then sooner or later, after 10 years, you're programming C++ still the way you did program and learn it 10 years ago. And this is the idea of this was that I teach all the things that I usually see in my trainings that people don't know or should know better, something like that. But still, average programmers, not foundation library programmers, or so. So and that worked well. It worked. It was. I think it was sold out. So I think it's an opportunity to do it again.
Let me ask you this question from your perspective. You know, I've been now training for several years, but I would say if I were to go back 5, maybe 7, maybe 10 years ago, most regular C++ programmers, I don't think use templates very much. They use them in the sense that they use them for other people's libraries, vector and things like that, but they weren't writing template code. Has that changed? Do normal average C++ programmers reach for templates more often than they used to?
Yes, without knowing that. So you're right. Well, I would say the average programmer hates templates. Period. End of discussion.
Yeah.
And especially meta programmers.
No, they hate templates. They hate to implement templates. Just an ordinary easy template, computing the maximum of 2 values, and because it's a smell if you use templates as a programmer. And if you use the vector, it's fine. But the moment you program templates yourself, you have a problem in your usual programming group. And there's a reason for that, because people have problems to maintain that. But that has changed something.
Yeah.
And the interesting thing that has changed is Lambdas. Well, Lambdas with auto. So the moment in C++ 14 we introduced Lambdas with arguments taking auto, the people didn't know that they in fact write a template. But they did. It was just a syntax. They didn't see that they implement a template, and suddenly they use it and they like it. So it's the interesting experience seems to be that they hate template and they don't feel comfortable as long as they see that they programming templates. But the moment they don't see it anymore, they like to program generic code, and that seems to be a difference.
Yeah, could be. I got to tell you, when it comes to syntax, I reach for templates quickly, because I would rather write it once. I don't want to write it for different types. If I can write a single solution, then that's what I want to write. However, if you ask me, well, John, I want to write a class, and I'm going to write the template member function out of line, I start to get, okay, I'm going to be reaching for the template book to get the syntax on that. And then I want to specialize. Let's say I wanted to partial specialize a template member function that's written out of line. Wow.
Especially with a template.
Yeah. I'm just terrified because of the syntax. It's like, am I going to get that syntax right? Syntax is really off-putting. So I think you're right in that Lambda with autos, which of course it's a much simpler situation. You're never going to specialize that, and blah blah blah. However, the fact that you're using a template isn't scary at all. No angle brackets in sight.
Well, as you say, we are not specializing lambdas. That's not true. We have this new feature in C++ 17, the new way to program polymorphism using std variant. And variant will be the next revolution in teaching C++ in a way that this is the way you should program polymorphism, because runtime polymorphism with inheritance is a nightmare because it introduces pointers, and compile time polymorphism doesn't allow inhomogeneous collections. But polymorphism with variant does introduce it, and then we get this nice little keyword, this little library feature called overload, which we to some extent discussed whether it should become a keyword or not. And this feature will able to overload lambdas. And that means that you can write a generic lambda to say, well, for these and that types, I have a generic way to print out something, and for this special type, I have this special way. So we will have some kind of specialization for function templates by using this feature, which will officially come in C++ 20, but we can already support it by 3 lines of code in C++ 17. So there is something.
Okay, that's not the least bit terrifying. So do we want to do a bit of a roundup before we get any deeper in this? Talk about what's going on with conferences, talk about what's going on in the world of C++?
I think we should.
Okay, your conference is coming right up.
It is, yes. Less than a month away now. So things are really stepping up a gear. Registrations are going very well.
So you should say the name of the conference.
I'm trying to remember, actually. C++ on C. I'm sure regular listeners will be familiar. And somebody here is doing a workshop.
Well, I heard that you got an incredible number of submissions for both workshops and talks. So I'm assuming you got top flight speakers and workshop. Is that correct?
Yes, that is correct. But we also We also have Nico doing a workshop.
Thank you. Cheers, guys. Cheers.
Nico slipped in there somehow.
Who's a step above top flight.
Oh, okay.
Happy New Year, by the way, to everybody.
So what's your topic, Nico?
Modern C++ template programming.
Okay. All right.
So I actually had a question about that.
Oh.
Is that modern C++, comma, template programming, or modern C++ template programming?
It's probably modern C++ template, comma, programming.
Right. Okay.
No, just joking. It's focusing on templates, because I think that a lot of people are scared, and we just talked about that, about templates. So they use it a lot, they use them a lot, but they have no real clue and feeling more or less comfortable when using them, and especially have problems to implement them. So it's not for experts. It's not for people who want to implement meta programming, cool features, compile time computations with templates, etc. It's more for the ordinary programmer who should understand better how to use templates and how to benefit from templates and where the borders are, and especially with the new features of C++, of modern C++. So 11, 14, and 17. When last year we published the new edition of C++ Templates, a complete guide, I learned a lot, because we were 3 authors. 2 of them were the experts. I was a non-expert, but the requirement was they have to write it in a way that I can understand what's written in the book. And that was my role. And from that, I get some understanding. I can confess that I did only understand half of the first edition of the book, but now I've probably understood 80 to 90%. And the idea is to bring templates to the ordinary programmer and to make it more understandable and more usable. That's
well, I think the language itself, we're getting better features, so we can do more with templates. It's not quite as painful with some of the things we can do. No? Isn't it getting easier? You don't think it's getting easier?
You are the first one in my life for the past 10 years who says new C++ versions make programming in C++ easier. How come?
No, wait a minute. I'm not saying there isn't more to learn, but I'm saying there's more tool. There's more things.
Some things get easier. Some things get easier.
Yeah.
In C++, we have an interesting situation. The situation is a lot of things are very easy, self-explanatory, as long as you don't look behind the curtain and into some details, and then suddenly you're getting frightening a lot. And we have, I mean, the authors of the C++ templates complete guide, the 2 others were experts in this area. One of them is implementing a compiler, which is used as a backend in a lot of other compilers. So David van der Voort. He was surprised about things that were invented in the last 5 or 10 years using templates. So to some things we were done with the book, and then there was this guy who suddenly used a very interesting new feature using templates in a very interesting way, and suddenly you could do crazy stuff, but as usual with templates, with a crazy syntax, because templates were never designed to be used like we use them.
Right.
And that's the current situation. So yes, some things went better, but most things went worse. I give you an example if you like.
Mm-hmm.
You know, make pair.
Mm-hmm.
So the function template we use as a convenience function so that you can create a pair of 2 values of different types.
Right.
So we had that in the past. It was just taking the arguments by value.
Okay.
It turned out in C++ 98 that if we take the arguments by value, then we first took the arguments by reference. as we learned it, because you pass two elements of two different types and you take the arguments by reference. The problem was if we pass two string littles of different lengths, this became two different types.
Right.
So with C++03, we switched to pass by value because it was a simple solution that worked everywhere. And then we introduced move semantics. With move semantics, we still want to support move semantics with make pair. So we used references again, but fortunately, we had invented something new, which is type traits. So type traits can be used to decay types. So that means to convert an array type into a pointer into the corresponding pointer type, and we use them there. So if you now look at the implementation of make pair, a very, very little function, just taking two arguments, returning a pair of these two parse elements.
It seems like it'd be trivial to write.
Yeah. And it's not.
It probably was in 98.
Well, and the same is true if you look what happened with std pair or what happened with std tuple, which are fundamental data types, vocabulary types for just defining structures on the fly. Tuple now has 38 constructors.
Right.
So, and that's the combination of the good things we went with C++, caring for performance. Performance is the key. And then templates.
I seem to recall that Louis had written his own tuple class for HANA specifically because he said the compile time of the standard tuplet class was getting killed by having all those constructors, because the compiler had to look at all those constructors to see which one was the closest fit, and so having all those constructors was destroying his compile time. So he wrote his own template, his own tuple class, just for performance of compile time performance. There's a lot of stuff going on right now with education thing. In San Diego, we created, or the standards committee created, study group 20, which is an education-oriented study group. And I'm on that mailing list, and I'm telling you, there's just a ton of discussion going on. There's going to be a telecon tomorrow morning, and I'm hoping to be able to listen in on that. I think there's an awful lot of, we're trying to figure out where our feet are. I mean, I don't think there's much progress being made on right now, because everyone's just trying to figure out, what are we trying to accomplish with this? So it's very, very early days, but there's clearly a lot of interest because there's so much going on. There was a Reddit thread just recently where someone at, I think, Code Academy has just recently published an introductory tutorial, a very, very introductory tutorial on C++. The first 4 modules were available or something like that. And so somebody was on Reddit and saying, please look at this. And he asked some questions. And one of the questions was, what should we do about returning from main? Should we just skip that altogether? Because in our hello world, we don't actually need the return. But what should we do? And it's this example of something, if you really want to explain to beginners, which is not, the kind of training that we do at CPPCon, we're not really base beginners. But if you want to explain something like this to beginners, if you want to defer all the details that aren't really necessary for beginners to know. And main has special rules that no other function has. It is the one function that if you have a return, which you have to for main, you have a return type of int, you can ignore the return. Every other function, you have to specify what the return is. So this is a special rule. And my best practice for teaching people is, when you're first teaching people, you don't teach all the special rules. Let's just teach the main thing. So what that means is you're going to have to specify a return for main, because otherwise you have to explain to people why it has a return type, but you're not returning. And there's other special rules about this return, right? On top of which, if you're going to say, well, we're going to return 0, now you have to explain to people what the semantics of returning 0 is. So probably, and this is what I came down on, I think that the simplest thing to do is, in your code, just say return exit success, which is the constant defined for the semantic of success, and maybe put a comment there saying, telling the OS the program successfully executed. But the problem is, you now have to include C stdlib, because that's where exit success is defined. You're doing all this. I mean, what a new user hostile language. There is, I think, a discussion, and it actually came out of the modules thing, but I think there's a discussion now that maybe main could just return void. This would solve so much. What?
Modular main.
Oh. So it's not actually main
only in a module.
Oh, that's so painful. We really need to fix real main. It should just return void.
Well, I think the idea is that modular main will become the default.
Oh, so there won't be a main in your main code.
No, you'll just have it in a module. Everything will be in a module. That's the idea.
In 16 years, yes.
Yeah. Well, But the point is, what a user hostile, a student hostile language, right? That you have to explain all this stuff in order to write hello world. Or not explain it. Kate Gregory talks about there's a certain amount of stuff that you can just hand wave and you tell students, I'll explain all this stuff later, just trust me on it and just do this for now. And of course, that is probably the best solution, but you want to minimize how much you have to do because students feel that weight of, okay, I'm trusting you, but now I know there's all this stuff I'm going to have to learn that's obviously complicated or you'd have explained it in the first place. What a mess.
Yeah.
So, well, first of all, I agree. The funny thing is I do C++ now for 25 years. And most of the time, more than 20 years, I was involved into standardization. We made a couple of mistakes. That's for sure.
A couple?
But that's of course. But that's sure. We develop software. C++ is a piece of software. It's a big project, and we develop a piece of software which is a framework for others. Who doesn't know better after 20 years ago? And beside that, we have to be 45 years backward compatible. Because 45 years C was invented. And we are still compatible to that. So that's a big problem, but that's also a big success factor of C++. We have to deal with that. The funny thing, I'm for whatever reason, I just started with beginner trainings again about the past 1 or 2 years ago. So I did it 20 years ago in my first company. And then I only did advanced trainings about library and etc. So my expertise. And now I'm doing full-time C++, which was not always the case. And just most of the time giving trainings. And so, of course, companies ask me, can you teach C++? And then the first discussion is, what do we teach? Should we teach old C++, new C++, modern C++, how to initialize an object, etc.? So even beside main, there are a huge number of interesting questions where you have to decide what to teach and how to teach.
Do you teach any classes long enough to explain how to initialize an object?
Well, the other thing is that people still think 1 week is enough or 4 days is enough. Oh, yeah. So no, and to some extent, it should be enough for basic stuff. I agree with that. It was enough 20 years ago. But 20 years ago, we didn't have this rich amount of library. We didn't have this rich way to use templates, etc. It was pretty clear what we had to teach. And this has changed. The language became a significant amount of more complex. And we still think we can teach it in 1 week. And excuse me, but we still have to be able to teach in 1 week at least to start with programming. And that means that we need to solve some of the issues you raised. So I was in the coining session of this SG20 working group. I think my outcome was, yes, we agree you can teach C++ differently, but we should fix some things in the language so that you don't have to teach crazy things at the beginning. Just start with rules that ideally apply all the time. And I give you some examples where I usually run in. So return not turned out to me that complicated. I just one comment to your return statement. If you end up that week and you have taught them that at the end there should be a return 0 or something like that, and they see the first commercial program of their colleagues and don't see a return there, they are totally confused. So we have to teach something about reality. So
eventually, but that doesn't have to be, here's hello world, and there's 30 footnotes on that to explain it.
Well, my footnotes are 3 or 4 slides for hello world. Yeah. Yeah, I have them. And by the way, I don't teach exit success, but I teach return 0 as being optional. That's all. And I teach this as a special rule for main, and that's okay. What drives me more crazy in main is command line argument processing. Because we have this crazy C string type, which we still support in C++. And we have no easy way to deal with that. And every trial to come up with an additional main definition of main, where we directly get in main an array of strings, was rejected so far. That would help me a lot more. Well, maybe not, because I have to explain how to maintain all code. Oh, that's a phone call. Probably complaining about just what I said.
I'm just phoning it in today.
So, and next thing, on the first day, the next thing. So I can only tell you about the crazy things I have at the first day. So next thing is how to initialize an object.
Hello, you're not available now.
We have some
I don't know how to turn that off.
So how to initialize an object?
I'm sorry, we're not available now.
So should we use curly braces? Should we use the equal sign? Should we use parentheses? And one of my account major topics is that I use a lot of my power and time to teach, well, the community that by default, uniform initialization with curly braces and without the equal sign, so direct initialization, is the best we can do and teach.
I agree with that, but I see tons of pushback, but I agree with you.
No, because C++ is driven by a community of experts. Experts understand C++. They don't see a problem with the problems you have when you don't know, should I use an equal sign? Should I use curly braces? Should I use parentheses? Because the latter is for classes, in the middle is for aggregates, and the first is for fundamental data types. And they say, yeah, that's the rules. We know the rules, so what's the problem? But for the beginners, they don't know the rules. So teach them one rule that applies most of the time and by default does the best. And it's clearly now, without any discussion, uniform initialization. It is. There are so many arguments in favor, and there's still so much resistance against teaching it. And that's what's driving me crazy.
Well, and I think they fixed the auto situation. What they haven't fixed is, and I don't know how they can fix it now without breaking tons of code, is the initializer list situation. The committee screwed that up. The committee defined that poorly.
Why?
If you could go back in time,
what do you mean?
If the committee had said that in order to have something be an initializer list, it needs its own set of brackets. In other words, if you wanted to initialize a vector with an initializer list, you would say, you know, vector v braces 1, 2, 3. And that would be unambiguous. And if what you said was vector braces 1, 2, then that would unambiguously mean to call the non-initializer list constructor that takes 2 integers.
Nobody understands why you need an additional pair of braces.
You would tell them the reason you need that additional pair is because it's an initializer list. And
why
you need to
initializer list something special? Why don't use it as an aggregates with just curly braces and that's it for all the value?
Because the ambiguity. Because the situation you run into where you don't know if you're trying to call the constructor with two integers or no. The committee The committee screwed this up. And if you could go back in time and fix that, then there would be no pushback on uniform initialization.
No.
This is the critical problem.
There is no ambiguity. There is a clear guidance, and the clear guidance says if you use curly braces, it does what you intentionally think it does. It's self-explanatory. Nobody, I teach C++, complains about using just single curly braces to initialize the elements of a vector. Everybody understands that. That's self-explanatory. The only problem comes because we have an old-fashioned constructor taking a size argument and a default value, but the problems only come with parentheses. And we all fall into the trap that we think we have learned C++ and that's a problem. No, it's not a problem, because all we can say is if you use curly braces, it does what you think it does. And then there are special ways.
No, because what I think, I have a constructor, it takes two integers, and I call that with uniform initialization. But it doesn't do what I think it does. It creates an initializer list of two items.
I don't get it. So if you have a vector taking in curly braces two values.
Yes.
Two integers.
Two integers. So you create a vector of two integers. What is surprising about that?
That my constructor says that a constructor taking two integers creates a vector with a certain number of items of a certain value. That's what the constructor says. There's the constructor.
Yeah, but that's what's my intention. That's why I pass two integers. They should be the values of the two elements.
No, not two elements. The number of elements is determined by one of the integers.
That's your history. You fall into the trap of your history, thinking that the first argument is special to the second. And that's because we had this constructor in the past. Think about.
But I might want to create constructors in the future with these sorts of things.
Oh, yeah.
The idea that just because an initializer list exists, all my other constructors can be broken, that's an unacceptable idea.
I don't get it. I mean, you agree that a vector taking two elements, and the first element has different semantics than the second, because the first element is a size and the second is a default value, then this is something special.
It's a constructor that's defined.
Yeah.
And I might want to do that in my class, not just a standard library, but I might have my own class where I want to do that.
Yeah. So the rule is, by default, curly braces do the right thing. And if you want to do something,
the rule is
use parentheses.
By default, curly braces mean it's an initializer list. That's a bad rule because it's not uniform initialization. This is what I want to teach. I want to say, if I'm constructing an object, that's what braces mean. And if I see braces, I know I'm constructing an object. And if I don't see braces, I'm not constructing an object. I want it to be uniform. That means I always use it. And this ridiculous rule that says, well, if you have a situation where it might be an initializer list or it might not be, then the fact that you tried to be uniform means that you have to do an initializer list. That's a ridiculous rule. The consistent rule would have been, no. If there's an initializer list, it must have its own set of braces. Had the committee made that decision, then uniform initialization would not be broken. But as it is, it's badly broken.
Is this a problem people have in practice?
Yes.
Yes.
Okay.
Oh, absolutely. If you have code, and I have examples. I have code like this where I construct a hash table and I gave it an integer saying this is the default number of buckets. Yeah. Because that's what the constructor of a hash table is. Then I go through and I say, oh, it's now I want to use uniform initialization, so I can change my constructor to now use braces, and I have a completely different result.
Yeah.
And that's really subtle. But when I tell people use uniform initialization, use braces, but I also have to have this big asterisk that's almost as big as the entire feature saying, unless there's the possibility that it might be interpreted as an initializer list. And then you have to put a comment next to it, say, do not change this to braces, because if you do, it'll be interpreted as an initializer list.
No,
it was huge. What they should have said is, if you want to construct, call the constructor, you just use braces. If you want that constructor to be interpreted as an initializer list, have a second set of braces inside, which is what we do if you have two arguments. Suppose you had an initializer list followed by an integer. Then you have a nested set of braces. That's what they should have said. If they'd done that, it would unbreak uniform initialization. But the reason that people are pushing back on uniform initialization is this trap. So saying, int I equals 7, which to me is awful. You should have, for years, I've been saying parens of 7. And now I want to say braces of 7. But, and that works fine for things like int. But as soon as you have another type, that might have an initializer list, it breaks. The committee screwed this one up. And I don't know how to fix it. I'm surprised they fixed the auto problem. They broke code to fix the auto problem. You know what I'm talking about, where you say auto, I, and then put it in braces, where that used to be interpreted as an initializer list, and now it's not interpreted as an initializer list. Well, they broke code to fix that, and I applaud that. That's wonderful.
No, well,
I would actually be willing to let...
We make
what's that?
Even worse there. But that's a different story. Let me answer two things. First of all, now I see your point. You say, if I have written old code, I should not blindly replace my parentheses by curly braces because this will change semantics. That's a problem. Because
even with new code, because if you were initializing a vector with these two integer arguments, I think you need to put a comment next to it, say, don't change this to braces because you'll change what it means.
Yeah. Okay. So we have this.
And that's terrible.
Yeah. But the problem is that the new design is fine. We should not have this old constructor. So we're talking about the problem of backward compatibility. What we should have instead is a constructor for vector taking as a first argument a special type, so that you have to write size and then your integer argument, comma, and then the default value. So we need a special type so that you mark in your constructor the fact that the first argument is something special. It is a size.
I agree that works around the problem, but that is not a solution, because that is saying that you're still in a situation where someone writes a new type and they want to now make it initialize a list. I mean, the idea that sometimes you should be able to write a constructor that has parentheses, and if you change those parentheses to braces, you completely change the semantic. That is just unacceptable. That is a broken
and that's
feature.
A bad design of the vector class. The vector.
No, because that's true of any class.
No.
That's true of any class. You change the semantics when you change it from parentheses to braces. You change what that means. Because it used to mean call the constructor that takes these arguments. But now it means call the constructor that takes these arguments, and if there's an initializer list, choose it first. And that's just broken.
Well, not always choose it first, but that's a different story.
No, that's what you're saying. Choose it first.
Unless, well, it doesn't matter. Okay, so, okay, I see your point. And I see it a little bit differently, I have to say, because...
I'm absolutely certain I'm right about this, but I don't know what to do about it, because we don't have the time machine to go back and say to the committee, don't do this. And I will say this. When I read about this, I was uncomfortable, but I said, well, here's this hard situation. The committee has to do something, and there's no clear winner solution. And for years, I said, well, I don't think they made the right call, but I'm not sure what the right call is. Now I'm sure what the right call is, but it took me years to figure that out. Yeah. So in the sense, I'm very critical of what the committee did. They screwed up. But on the other hand, I'm also very sympathetic, because had I been in the room at the time, I couldn't have told them what to do.
Which is to come to your other issue, which is the issue with auto and initializer lists. I was in the room when this was voted, and I was not aware of the big disaster we created there. Because you said this was fixed. No, we made it a little bit worse even. Because
wait a minute. Okay.
Should we review what the problem was in the first place?
Yeah, so the problem in the first place was if you declare something with auto, and then we initialize it with an integer value with curly braces. So auto x, and then curly braces 42. by rule, this was an initializer list and not an int. And everybody thought, and reading the code thought, this is an int. We were not aware of this problem until we found out, and then things got worse. So we fixed that. In fact, we fixed that by breaking existing code, or by possibly breaking existing code. But the huge mistake we made is we only fixed it for direct initialization, which means for using no equal sign to pass the initial value. If we now use auto x equals curly braces 42, it's still an initializer list. And that's a nightmare. That's a nightmare which was driven by one. Just let me finish. That was a nightmare just driven by one of the biggest companies we have here in the world. Again, argumenting it, we need this way of initializing an initializer list, but it means essentially that using an equal sign in an initialization changes the type of what you initialize. And this should never have happened. But the people who argued in favor of that still don't argue in favor of that, still argue in favor of that and say this was the right decision. And that's the typical expert thing.
I agree that was broken. However, I don't worry about that as a problem, because I tell my students the way you initialize something is with braces, no equal sign. It's not an assignment, so get the equal sign out of there. It is initialization.
We teach the same. So now we come to the point.
However, and when I teach them this, I say there's two problems. One is the auto problem, which has been fixed.
Mm-hmm.
And it's fixed, as you said. The better way, instead of saying I understand why someone might want to create an auto initializer list, because there's a single use case that I know of, and that is, suppose you want to call 3 functions and you want to make absolutely certain you're passing the exact same data to all 3 functions. Because almost never do you create an initializer list. You create them only as parameters. So creating an initializer list object is a rare situation. So that's why people tripped over this all the time, because they weren't trying to create an initializer list. They were trying to create a single object, and it became an initializer list. But you might want to do it. I mean, it is a valid use case. And the way to have done it would be to say, oh, well, then you use 2 nested initializer lists. Nested braces would say, I'm creating initial. That would have been the solution. But I don't worry about this, because I tell people simple, consistent rules. And the simple, consistent rule is always initialize using braces. But then I have to say, unless there's the possibility that that's interpreted as an initializer list, and that's not what you want. It's a huge blot of an asterisk. And I see it in my own code all the time. I'll be going through something and I'll notice, oh, I'm initializing something here with parentheses instead of braces. I should change that. And then I realize, oh, that's because there is an initialize. And the classic case is every time I look at, I'm initializing a hash table and I'm initializing it with parentheses, and I keep saying, oh, I should change that to braces. And then I realize, no, because if I change it to braces, I'm not specifying a number of buckets, I'm specifying an initial value.
Okay.
It's just a huge, huge pain point.
Yeah.
And I think that's part of the reason, because I've talked to people and say, we should use initializer lists or a uniform initialization. And they always push back and say, no, because it might be, I'm writing a template code and I don't know what T is, and T might have an initialization that's
So it's
a huge pain point. And I agree with you that when they fixed it, they didn't fix it quite the way they should have fixed it. But like I say, it's one of those things where it's like, you shouldn't use this feature this way. And the fact that it's bad is all the more reason why you shouldn't use this feature this way.
So, but it's funny that we talk a lot about this problem and that we have so much disagreement.
It's not funny. It's sad. It's sad.
Yeah.
When you log into the C++ Slack, there's this message that comes up every once in a while. It's rotated, cute little messages. And there's this quotation that says, C++, where initialization of objects is an expert topic. That's just so sad, because
so the interview becomes a little bit interesting, because you are the one stating here all the initialization rules, and usually what you say is my point, and I'm becoming in a situation where I where I say, well, there's some useful thing behind, and usually it's a different role. I play your role, so that's funny.
Usually I understand. Usually you're the initialization cynic. You're usually the person who's. Am I wrong? You're usually point out, here's this gotcha, here's this gotcha, here's this gotcha.
Well, I fix all. I try to fix all of the flaws I saw, and so a few things were fixed based on my power, and some I supported. So because we had some other flaws like initialization with curly braces didn't work properly for aggregates, didn't work for atomics, etc., which I tried to fix, or some people I supported that fix that, so that I at least can teach by default using curly braces is the best you can. There are still exceptions.
Right.
Where
I'm completely on board. I do teach it. I teach the braces, but this huge asterisk next to it, where unless it might be an initializer list, then you can't do it.
I got it.
Every time I do that, I cry myself to sleep.
Did you read what AppSale recommends? So the Google Style Guide?
I have stopped reading the Google Style Guide because I prefer Stephen King for horror stories, and the Google Style Guide is not nearly as compelling a horror story. It's no less a horror story, but it's actually, that's unfair. The Google Style Guide is improving a lot. It used to be really bad, and now it's not as bad. And the people at Google who understand C++ have been working on the Style Guide and improving it. That's wonderful. The original author, I don't think, understood C++ at all. The original Google Style Guide was written by someone who didn't understand C++.
That's interesting. We should have talked with them. And no, I mean, the point is, so let me try to make something out of this discussion, which is a little bit interesting, the discussion today, because it's focused only on one topic. So just to generalize what our problem is.
Yeah.
So the problem we have now is we have a language that has grown over years. We have a library, so both core and library. And it became much more complex over time. We have a clear guidance to say don't break backward compatibility. We have experience why this is a good rule. So look at Python. Look at what happened with Python. We have de facto 2 Pythons in the world because they did break backward compatibility. And that's not something we're keen on. And and I have other examples in service-oriented architecture. They introduced a SOAP 2.0, which was never used in the community because it broke existing standards. Maybe not SOAP, maybe WSDL, so we're still, maybe not. So we have this crazy beast of backward compatibility for 45 years now. I said we made mistakes. My opinion is the constructor of vector was a mistake. If we wouldn't have that constructor, things would look better. And if people have control over their class, there should be a good design, not falling into the trap we have in vector now.
This is the advice I give to users is when you're constructing your classes, don't allow this overload to happen. As you said, make a special type, make an enum type, do something so that the signatures can never collide.
Yeah.
However,
we run into the problem.
It's still a workaround of a flaw in the language.
But but the general problem behind it's not only initializer list. We have the interesting roots of overload resolution. And they are not only surprising in that area. We have other surprises. For example, that, I don't know, a constructor taking templates arguments wins over the copy constructor, which also creates some interesting consequences. So we have some implicit interpretations and conversions that create interesting problems. My point is, though, I would love in this teaching education group of C++ to talk about these issues and to solve the issue in the following way, that we come up with a common set of guidelines, because that's the only rescue we have in C++. C++ is far too complicated now to teach as a whole. It's far too complicated now. So we have to decide what we teach. We have to decide what is good practice, what is good style, what is bad style, what is bad practice. And the next step is that we should agree on that. And I don't care, it matters who we teach. And that was some outcome of the initial group of SG20, so the educational group. It matters who we teach. Because, for example, for beginners, we might say, for just the first beginner, we might say, just an ordinary constructor, initializing a member. Take the argument by value and copy it into the member. The next step would be to say, for those who are more experienced, take it by reference and then copy it in the member. And then when we have people who have understood move semantics, we would say, no, take it by value and move it into the member. But you don't want to teach move to beginner training in the first week. And then for those who care about these performance of move, so the foundation library programmers, they would say, no, overload all the different ways of supporting move semantics and not, and having, I don't know, 10 constructors instead of only one or one generic one. And that's a problem. So that's one thing I learned from this group is, from the discussion of the initial discussion of SG21, the way we teach C++ and the style guides we invent depend on the audience. So we will have different style guide for different audiences.
I think there's a much greater differentiation in audience, and I think it comes out of two of the keynotes that we had at CPPCon. One of them, keynote speakers, I should say, because she wasn't talking about this subject, but Kate has famously given a talk on, stop teaching C. And what she's saying is that when teaching C++ to new people, don't teach C-style strings. Don't even teach pointers. Go directly to references. Don't teach arrays. These are the old ways of doing it. Teach them vector and teach them the string class from the beginning. And I think most C++ experts agree with that. On the other hand, Dan Sachs points out that if you're teaching a bunch of people who are comfortable with C, and the first thing you say is stop using arrays and stop using string pointers and immediately start using these classes. Someone on Reddit was just talking about the insanity of this, because what you're essentially saying to someone, somebody who's using an array on the stack, and you say use a vector class which is going to do an allocator, they think you're crazy. And on the other hand, you say no, I just want you to do a vector class when you would be doing a resizable array, but already the C programmer is not thinking of that reallocatable, that malloc. They're not thinking that as an array, even though that's really what it is, because they think of an array as something that is on the stack. It's a local thing, or maybe a member of something else. The point is that's a much greater divergence in terms of audience. What you want to teach someone who has significant C experience, the advice to not teach C first makes great sense when you're talking to someone who doesn't know C. But when you're talking to somebody who has a great deal of experience in C, you're talking about the embedded community, you're talking about that audience. The guidelines of how you want to talk to them are completely different. And encouraging them to use vector and string as opposed to what they're comfortable with already, that's insane.
Okay, John, here's my question.
Yeah.
In your first week, would you teach polymorphism?
If by that you mean traditional object-oriented polymorphism,
I asked
probably
about
not.
Polymorphism in general.
Well,
Then my next question is, which kind of polymorphism would you teach now? And then the next question is, if it's runtime polymorphism, so with inheritance, how do you avoid pointers?
Well, you can teach polymorphism with references. That's what Kate was saying. She said you can teach polymorphism with references.
What? And even using inhomogeneous collections? No, you can't. It's a vector.
Why not?
No, it's not possible. if you have a vector of circle and line.
Yeah, but what she's talking about is you can teach it as I'm calling this function. The function takes a reference to a shape.
Yeah, I know.
And it's not a pointer to a shape. It's just a reference to a shape. You don't need to talk about pointers at all.
You can also teach polymorphism using variant. Not sure I'd recommend it in C++, but that's perfectly valid.
That's an interesting question. The question is whether the beginners week should teach variant instead of runtime polymorphism and virtual. That's one of the things I have now in my training for my training session.
Yeah. If you look at what Kate was saying, of course, she was never saying don't ever teach pointers. What she was saying is it turns out that if you teach references first and then teach pointers, pointers make a lot more sense in the context of you already know what a reference is than to teach pointers first and then try to explain what references are. Now,
I agree with that.
I don't teach beginners, so I don't have that experience. But she said that's what she tried to do, and it worked very well.
Good. I could imagine that. I try out different things now, and I don't have an answer to that. And you raise the right question. So should I teach pointers or not? What should I teach instead? I don't think we can skip pointers a long of time. And the other thing is
I would encourage you to try it because Kate did and she said it worked. Teach references first and then teach pointers.
The funny thing is if you have people coming from Fortran, they are surprised by call by value. So they usually say, oh yeah, call by reference, of course. If you pass something, modify it.
Isn't that what Java does and is more likely that you're going to teach? I mean, I've never been in a class where someone said, well, I really mostly know Fortran. I've been in classes where people knew Fortran, but I've never been in a class where the person identified as essentially a Fortran programmer who was trying to learn C++.
Fortran, yeah, they come from Fortran to C++. That's interesting. Because they're to some extent they're used to call by reference, which is not the same call by reference as with us, but it has the same consequences.
I see.
And they are surprised by call by value. So,
but I would imagine that's what the Java. I mean, isn't that more likely that that's a Java person or even a Python person, right? I mean, if I pass a list in Python, aren't I really passing a reference to the list essentially? I mean, isn't that? That's what I thought was
maybe, but in Java we have the fundamental types. Yeah. Okay.
Yeah, in Java you don't really get to choose whether something's by value or by reference. It's just a property of the type.
Yeah. The whole discussion we have here right now says C++ is no longer teachable. That's all. It's no longer teachable. And 1 week is not enough. And we at least we experts in the community should agree on what we teach. And we don't even agree on how to initialize an object. And that's a nightmare we have.
So I make a pretty good living teaching C++. So I contend you're wrong in saying it can't be taught. I am sympathetic to your point of view that saying it can't be taught in a week.
But you also said you're not teaching beginners.
Yes, but to say it can't be taught is too open-ended. You have to qualify it and say, oh, it can't be taught. You know, I can't take a beginner and teach them how to master C++, but I would contend you couldn't take an expert and teach them how to master C++. If what you mean is you're going to teach them everything about C++. There's nobody who knows everything about C++. Exactly. I heard somebody today saying, you know, Bjarne described himself on the expert of C++ level on a scale of 10. Bjarne describes himself as a 5. I have no idea if that's true, but it wouldn't surprise me. I mean, the idea that somebody actually knows everything about C++, again, we're talking about Richard Smith and no one else, right? And even then, he probably doesn't understand most of the library stuff, you know, because it's, but
Bjarne has downgraded himself from a 7.
What's that?
Bjarne has downgraded himself from a 7, has he?
Did he used to say 7?
He used to say 7, yeah.
Yeah, I have no idea. I think it is one of the things that, you know, asking someone to rate themselves on how knowledgeable they are about C++, and then anyone who says that they're greater than a 5 just assume they don't understand. They don't know how much they don't know, right?
That's probably true. Yeah. Yeah. So, but yeah, and if we would, I talked with Scott Myers about this problem recently, and Scott said, well, 15 years ago it was easy to write a book like Effective C++. Because we had a common sense about what's right in style. So we have the language features and we know how to use them. This is no longer true.
I think this is one of the problems, and I think you're hitting right on it, is one of the problems that the education group is going to face is that there are some people who are going to say, you should use uniform initialization, and other people say, just don't. Just say equals, int I equals 7. And leave it at that. And other people are going to say, no, if we want uniform initialization, we should use it uniformly. And don't even get into East const, right? I mean, there are fundamental disagreements people have about, should we be teaching object-oriented programming? I mean, this is this weird situation where I go to conferences, no one is talking about the virtual keyword. No one is talking about traditional runtime object-oriented programming. But when I get out in the real world and I talk to people, that's what their code is. And some of them go to conferences and they realize this is not cutting edge stuff, but this is what I have to support. But an awful lot of the people in my classes, that's what they think C++ is. C++ is runtime overloading and virtual keyword. And that's their idea of C++. And I don't take it as my mission to fix them on that.
Well, because the community fails to propagate the new way of programming, and the problem is which would take that we agree on the new way of programming, and we don't do that.
No. Even if we, meaning the people who go to conferences and the people who are trainers, even if we agreed, as I said earlier, it would take 1,000 people, literally would take 1,000 people out there training people. Suppose you and I and everybody at Cpp.chat, we all agreed, no, runtime polymorphism is dead. It is not the right way to do it. And I think largely that agreement takes place. But that's not changing the 4 million people who are writing in C++ right now. And that's not going to happen.
About that.
No,
that's about that. That takes its time, but it would be a beginning.
Partly because the people who we're talking about as experts are not college professors. College professors are seen as experts. They turn out, 30 at a time, groups of people who they've taught C++, and to them it is runtime polymorphism, because the class isn't really a C++ class. The class is actually a class on object-oriented programming, or it's a class on something else.
That's a different area. I mean, that's also an area we have to face, but first of all, we have to agree. That's the first step. And
what that means is that, I get a week with 20 students, whereas that professor gets an entire semester with a lecture hall of 150 students or whatever he's teaching. In other words, they're cranking out more people. They're creating legacy programmers faster than we're fixing them.
Yeah, but we don't fix them. Let's start with our own.
So
and our own means we agree.
My view is we should be okay as long as Scott Myers doesn't retire. But actually, I think we're out of time, and technically we haven't quite got out of the news section yet. We never quite finished that. So maybe we'll have to do the news next time.
Yes. So next time we discuss about C++.
Maybe we'll go on to that as well if we're lucky.
This has been so much fun. I thought the interview we did at CPPCon, teasing this for people who are listening to that, I thought that was great, but I think this was even more fun. So looking forward to having you come back. Maybe we'll talk about what to teach in the second week of C++. Or even on the second day.
Okay, interesting. It's the problem is the fight we have here is the fight which leads us to nowhere. Doesn't it?
That's a good closing thought.
Very depressing, but good closing thought. So we usually wind up the show by wishing everyone safe coding. Are we ready to do that?
Yeah, I think we are. So safe coding, everyone.
Safe coding.
Safe coding. Good. Cheers.